the color
The ones you visited. That'll make counting easier later.
Yeah.
We got over here? I think we're good. You guys got it?
This I can't.
All right. Yes, ma'am.
Will you hand these to him?
And Danny brought up an awesome point last time, plus or minus point. We're going to get into it today. So there's this idea that we can find the center of a data set, which is true. We can find the center of a data set. It's completely possible. And required in many cases. On average, what's happening? On average, what's happening? Once you have the average, though, that can sometimes paint an incomplete picture. Certain data sets can have similar averages but widely different consistencies or inconsistencies, i.e. variations. And that's what I wanted to get into today, finish up today, is making sure we have a nice understanding of that idea of variation around an average. So, and I heard Stacy was standard deviation. That's the one I really want to hit on today, is the idea of the sample standard deviation. The last thing I did in class last time was draw a little 2x2 chart, if I remember correctly.
The last thing you did was do the standard deviation takeaway.
Takeaway, exactly, as in what it is. Thank you. Keeping my toes on here. So, the takeaway. If S is big, then the data is
Inconsistent.
good. Inconsistent, it's varied. Big S means we're stretching the data out, it's getting further and further away. Therefore, if S is small,
It is consistent.
it's consistent or clustered, very nice. And I put big and small in quotes, why? Because it is relative, right, Nick? It's relative to, I mean, is 0.1 big or small? Well, it depends. 0.1 could be very large if some other data set has a variance of 0.001. 0.1 is 100 times more variant. And if you're designing things like syringe tips for like an injector, that could make a huge difference. I mean, ow, right? I just got one of those, a flu shot. I don't know what the hell the guy, I think he hit like my bone on that last one. I'm still feeling it. And the pulled little butterfly, I'm like, ow. Still feel it a week later. So that could be big, but 0.1 could also be small if other variances or other standard deviations, 0.15, 0.21. It could be very, very small. So that's why I put in quotes, and we'll size it up more. That's one thing to think about. Intuitively, what is the sample standard deviation S? What's it measuring? And I'll get you started. On average, what's it measuring?
How far away it is from the average.
Good! How far away what are from the average?
The data points?
Perfect. If you look at all the data points in a sample data set, and you roughly calculate their distances from the sample average, and you average all those, that's basically what S is. And that's why outliers can pull S and make S extraordinarily larger than it should be. Because if you get one data point very, very far away from average, first of all, the average is going to chase that. But secondly, you're also pulling the average away from the other data points. I'm trying to design a video to explain that better right now using Excel, but it's not working. I'll keep trying. But yeah, it's an average distance, essentially. Did I mention, I guess you watched the vid, did I mention mu, little sigma?
Yes.
We did, okay. So the big takeaway is we're using little s because we're talking about a sample standard deviation. We're talking about a sample. Little sigma is the population, and that's great because it exists, but we don't ever know it because we can never get the entire population except for very, very small, very, very specific instances. Cool? All right. Now, I'm going to pose a question that will then take us a little bit further because we haven't gotten into Danielle's plus or minus idea yet, which I really, really want to hit today. It's very, very important. That's it, when you experience a standard, a deviation, or as Walter brought up last time, a margin of error, very often it's in this plus or minus form. I want to make sure that we kind of drive that point home. I put a data set up here on the first one on your data sheet. It's a weight loss, 35 subjects in a sample. And the study was called Nutrient Adequacy During Weight Loss Interventions, blah, 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 blah. It's a wonderful title, and it's all great. And I don't want to get into what the study actually showed. We'll do that in 244. What I want to do is I want to reconstruct part of the study, which was the analysis of these weight losses. So what you're seeing here is you're seeing positive and negative numbers. Positive numbers mean that during this study, subjects gained weight. Negative numbers mean that during this study, they lost weight. What I would like you to do is to find two values for me from this data. I want you to find the average weight loss, or gain, if it's a gain, and I want you to find the standard deviation around that weight loss. Okay? And use your TIs, please, to do this, yes? Yes, please don't do this by hand. Oh my God. How many of you have flashbacks to Bert and Ernie and the X? Yeah, no. I promised you in class, one time and one time only. And this is not that time. You already did that time. You're clear now. Use your TI. This is why we have technology. So we don't screw this up. Yes, let's pause this.